What do you call two friends that love math? Algebros. That's a good one. I like that one. I laughed when I saw that one. All right, so today we're starting calculating slope. Today we are calculating slope on graphs. So for a quick review, remember our equation this year is going to be in the form y equals mx plus b. But what do those things mean? My y, remember, is my output. My y is my output. My m is my slope. There's all those other words for m, for slope, but remember that's the one that we're going to use most often. Today in your extra Desmos practice, you'll see a lot of the other words used. The x is my input, and then my b is my y-intercept, where my line crosses the y-axis. Where my line crosses that y-axis. So in this explore activity, there are 3 different equations. We're going to use this calculator to kind of help us see how things change when I change my slope. So looking at my first equation, I have y equals 5x plus 3. So if I type that in my calculator, y equals 5x plus 3. I see I have this red line. As I look at that line, I see that my b, my y-intercept, where my graph crosses the y-axis, is at 0, 3. Because remember that b, my y-intercept, is 3. That means my graph crosses my line at 3. I see that as I go left to right, just like when I read left to right, I see my line is going up as I go from left to right. So that's our first equation. Those are the things we notice. We notice that the line goes up from left to right. Maybe it's just a smidge bigger. Oh, that's all right. There we go. We also said that we noticed it was also a straight line, right? Also a straight line. Let's do the next one. This one is negative 5x plus 3. I'm going to put it all in the same graph so we can see how they're similar and different. This graph has negative y equals negative 5x plus 3. Ooh. I see that my b is the same. It's still 3, and it's still going through that same point. But now I see if I go left to right, my graph is going down. It's still a straight line. My line goes down. It's still a straight line. And then my last one is just y equals 3. It's on my green line. If I still have y equals with just a plain 3 all by itself, and I see I have a straight line that still goes through that 3. That 3 is my b. It's my y-intercept. I'm not multiplying with it. I just have that 3. So this one, we have a horizontal line, but it's still straight. That's what my graphs look like. Let's talk about what these equations look like. When we had that straight line that was going up, what do you notice about that slope? We had a positive slope. A positive slope is going to make my line go up as I go left to right. When I had that negative slope, my line went down as I went from left to right. So here I had a negative slope. And then for this equation, y equals 3, is there a slope? No. There's no number with my x. That's the same thing as if I have 0 times x plus 3. I have no slope. It doesn't matter if I have it there or if I delete it, my line's not moving. There is no slope, or a slope of 0. with that line. Sorry, I need to move that spacing. There we go, so we can see it a little bit better. So whenever we see a positive slope, my line's going to go up. If I see my slope is negative, my line's going to go down. And if I don't have a slope, if I don't have an x, it's just going to be that horizontal line. So that brings us to the different types of slope. In math, there are 4 different types of slope, but in this class, we're only going to discuss 3 of them. We're going to discuss those types that we just saw before, where we had positive slope, negative slope, and zero slope. Oh, I guess I could have just drug those in there. There we go. We're only going to discuss 3 kinds of slope, but there are really 4. We'll talk about the 4th one a little bit, but we're not going to do any math with it. So here we're going to match the different types of slope, positive, negative, and zero, to their graphs, to their equations, and to what the line looks like. So looking at my graphs on the slide, which one of those is positive? Which one of those graphs is positive? This one. I know that that graph or that slope is positive because my line goes up as I go left to right. Left to right, my line's going up, so I know that that's positive. My negative slope, what does my graph look like? It goes down. My negative slope goes down as I go from left to right. And then if I have a slope of 0, remember that's just a horizontal line. Boom, straight across. So again, positive, our line goes up. Our negative slope, our line goes down. And then our slope of 0, we have a horizontal line. Horizontal line. And then the equations again that go along with it. Remember our slope, that's our m. Our slope is our m. So here I have a positive slope. 5 is positive, I have a positive slope. This one, I have a negative 5 for my slope. Negative 5 for my slope, so my line's going down. And this last one, y equals 3. There's no slope. I just have y equals some number. That's my horizontal line, slope of 0. So here's a quick overview of the different types of slope. Again, we have positive, negative, and 0 that we're talking about in this class. That bottom right, that's another kind of slope, but we're not going to talk about it in 8th grade. You'll get into that with algebra. And that's called undefined slope. That's where you have a straight vertical line. It's kind of the opposite of a 0 slope. 0 is horizontal, undefined is vertical. We'll talk about what makes slope undefined a little bit here in our lesson, but again, it's not going to be on your test. You're not going to see anything with undefined slope, just positive slope where my graph goes up, negative slope where my graph goes down, and then a 0 slope where I have a horizontal line. This video is called Slope Dude. Go ahead and pause my video and watch this. It has really good reminders of when your slope is positive because it's going up, when your slope is negative because it's going down, and when your slope is 0 because it's a horizontal line. Watch that Slope Dude video on your own. More matching, go ahead and see if you can do this on your own. Match the line going up, down, or it being horizontal, what the equation would look like, and what the graph would look like. Pause my video and do that on your own. All right, so again, my positive slope, my line's going up. My equation would be y equals mx plus b. Negative slope, my line's going down. I have a negative m, a negative slope. And then for a 0 slope, y just equals some number. It's my horizontal line. Y just is going to equal some number. Sorry, I'm centering that on the other slide because that's going to bother me. If you need a brain break, go ahead, pause the video, go take care of something, whatever you need to do, but then come back because we're going to keep going on to the next part of this lesson. Slope on a graph. We know what positive slope looks like. We know what negative slope looks like. We know what no slope looks like. Now we want to actually calculate it. What number goes with this relationship? We talked about it a little bit last class. With our rise, how far we go up between points, and our run, how far we go to the right. So we're going to be looking at these numbers between points on our graph. How far are we rising, going up or down? How far are we running, going to the right? Some reminders about slope. Remember, slope is the change between points on a graph. Slope is the change between points on a graph. How far up and down we're going, how far to the right we're going. Our symbol for slope in our equation is that letter M. Remember how we talked about all those other words for slope? Well, there they are. There they are. Let me stretch that out a little bit. Slope is also known as the coefficient, the change, the unit rate, the rate of change, the constant proportionality, all of those things. All of those things are words that mean you're talking about the slope. And the last one, the way you calculate it, like we talked about a little bit on that last slide, it's the rise over the run. How far up and down you go, and then how far to the right you're going to go. So the first thing that we're going to need to do, the first step to calculate the slope, is you're going to need to find pretty points. Now, these points aren't pretty because they look the best. Well, they kind of are. Points are pretty if I can read my graph and I know exactly what that number is. So if I look at this line here, if I look at that point, I know exactly that that is over 1 up 2. I know exactly what that point is. This black dot here, that's another pretty point. That's exactly at the intersection of my lines on a grid. That second black dot, again, right on the intersection of lines on my grid. And this last pretty point up top, again, that line's going right through those points pretty. Then I have these points that are not pretty. Like right here, I don't know if that line is exactly at 1/2. I don't know if it's a little less, a little more. I don't know exactly what that point is, so that's not pretty. This middle red arrow, again, I don't know exactly what that number is. That's not a pretty point. And then this last red one here too. Again, I don't know exactly what that number is. I can't read it. That's not pretty. So when you're trying to find 2 points, I want to see how far up and down I go, how far to the right. I need to use pretty points, not these red lines where I don't know what those numbers are exactly. So using that graph, we're going to start at our left point. We're going to start at this left point right here. And I need to see what my rise is to get to my other point. I need to figure out how far I'm going to rise or go up to get to my next point. So if I start here, I see I go up 1, I go up 2. So if I'm trying to calculate my rise over my run here was 2. I went up 2 spaces. Count the spaces, not the lines. I went up 2 spaces. How far up or down we go, that's my rise. Then I want to see how far I'm going to run. That's how far to the right I'm going to go. It's always going to be running to the right because that's how we read the graphs. We read them from left to right. Remember the run? That's my bottom number. So I see I went up 2 points. Then I'm going to run. I'm going to go to the right. 1, 2, 3 spaces. 3 spaces. So I'm going to plug in 3 for my bottom number. My rise was 2. I went up 2. Then I ran 3. I went to the right 3 to get to my new point. Your path kind of makes a little triangle. We're going to use these triangles in another chapter. So this is going to be important that we remember how to use the rise and the run to make triangles on our graphs. And the fourth step is to simplify the slope if you can. Looking at that fraction 2/3, I can't simplify that anymore, so that means that that's my final answer. If I would have gotten a number like 4/6, I could have simplified that. And I could have got that if I used different points. But for this situation, I get 2/3. I get 2/3. Let's look at another example. Again, the first step, I want to find 2 pretty points. I'm lucky this example already gives me pretty points. They're those red dots. Those red dots are my pretty points. They gave them for me here. So now we need to find the rise. We need to find the rise, how far up or down we are going. So if I come up top here, I find my shapes, I can go to where it says arrows, and I'm going to make myself an arrow. Remember, I go from the left point to the right point. So I see first, I'm going down. My first direction is that I am going to go down to get to my next point. I am going down to get to my next point. If my graph is going down, does that mean I'm going to have positive or negative slope if my graph goes down? If I'm going down, that tells me that I'm going to have a negative slope. So right off the bat, I know this M, my slope is going to be negative. So my slope, I went down how many spaces? 1, 2, 3, 4, 5. I went down 5 spaces. So the top number of my slope, my rise, is going to be a -5 because I went down. -5 because I went down. Now I'm going to do another arrow to see how far I run. How far am I going to the right? Got my new arrow. Oops, Andrea, spoiler alert. Now I need to figure out how far I'm running, how far I'm going to the right. And I'm going to count. 1, 2, 3. I went 3 spaces to the right. I went 3 spaces to the right. I plugged that in. I plugged in my rise, how far up or down we go. Then we plug in the run, how far to the right. And the last step is simplify if we can. Can we simplify this fraction? Can we simplify -5/3? Ooh. Can I simplify that fraction? I cannot simplify 5/3. No number divides pretty into -5 and 3. So that's my slope. That's my slope. If you turn it into a decimal point, you're going to get a repeating decimal, and that's ugly. We don't typically see decimals and slopes. You can have it, it is possible, but we want to leave it in fraction form. We want to leave it in fraction form. Maybe in a word problem, if you're doing money, you might see your slope there as a decimal, but typically in a math textbook, you're going to see -5/3 for your answer. You're not going to see that decimal. And there we go. Our slope is -5/3. Now on this, you try these on your own and then come back and watch the video to see how you did. So go ahead, pause it, click on one of those links on your slideshow, and it'll take you to some example problems for you to do on your own.